confuse other people. Okay, so rational expressions. Okay, so when we talk about rational numbers, like x is an element of the real numbers, or it can be a rational number. Rational numbers include everything that can be written as a fraction. Right? You guys remember that from grade 9? You've got natural numbers. What were natural numbers? Numbers that are 1, 2, 3, 4. They're whole numbers, whole positive numbers, but what don't they include? 0. So natural numbers don't have 0 in them. Whole numbers have 0 in them. So your circle's getting a little bit bigger, right? Natural numbers are the smallest. Ooh, this is what I do with my grade 9. This is why I have my matryoshkas in there. Okay? Oh, there's so many of them. So many little balls. Yeah. This one's from. They're either from Prague. Okay, they're from Prague. Okay. This is my little small one. Yeah, I didn't. Okay. So this is my matryoshka. These are my Russian dolls. So this is your natural numbers. They're the smallest group of numbers, right? And they can be contained inside the whole numbers. So whole numbers include the only thing inside of a whole number is a natural number. Okay, got it? Okay, then where do we go from that? Integers. What are integers? Negative and positive. Below 0 and above. Right, but what's special about them? They're whole. They're whole, right? Like it includes 0, but no decimals. So natural numbers, whole numbers fit inside of integers. Okay? All right, what comes next? So now we introduce the fractions. And so natural numbers, whole numbers, integers all fit inside rational numbers. So rational numbers include your fractions, but they also include everything else inside of it. So there you go. There's grade 9 lesson. And then I don't know what these would be my either, I don't know, this is the smallest group of everything. These would be irrational numbers. These are the stuff we don't talk about. They're imaginary numbers. They're the pi things, right? So, because pi can't be written as a fraction. Root 2 can't be written as a fraction. So inside of this, we have our natural numbers, our whole numbers, our integers, and anything that's a fraction. So that takes us to what a rational number is. So it includes fractions, but I expect that you all pick right. If I give you 2, can you write that as a fraction? What is it? 2 over 1, right? If it was 2 over 2, it would have a value of 1. We needed to have a value of 2. You guys with me? Okay. And we've done equivalent fractions. We've done all those things at some other time. So this is why you keep working nested cells in the classroom. You can teach numbers. All right. Okay. So what we have to do? Our rationals. Oh, what does this expression mean? No equal sign. So with this, we're simplifying. That's all we can do. We're not solving. We can't solve for x equals 2. We can't do anything with that. We're just getting that fraction to its smallest possible form. Right? Like just like if I gave you 6 over 12, the only thing I can do with this is simplify it. And my simplification would be 1 over 2. Right? You guys with me? So if it's an expression, the only thing we can do is simplify it. And there's different rules for expressions and equations. Okay? So you got to keep those straight. So right now we're just going to deal with expressions for right now. So rational expression, a fraction with a variable in the denominator. Easy peasy, you guys can do that, right? So now today we're going to talk about non-permissible items. That's what all today is. And I call them my NPVs. I abbreviate it to NPV just because I'm too lazy to write non-permissible values. It's a very long set of words I have no desire to spell or write. So here's the thing. We know in fractions, we can't have a 0 as a denominator. You guys know that? Right? It's all fun and games until somebody tries to put a 0. It can't happen. You can't break a number down into 0 groups. It doesn't make sense. You can break down into 1 group. I can break 27 down into 1 group. I can also break it down into 3 groups of 9. That's what division is. It's breaking things down into equivalent groups. But I can't break something down into 0 groups. But then that would be 1 group because you ate the 1 group. So how, like, it's kind of like how do I hold 0 apples in my hand? I just wouldn't be hold, like, then do I have an apple? 0 apples? Like, there's a whole bunch of questions that I think we're in a philosophy class now, and I'm not okay with that. She just gave you that it was undefined. Oh, okay. Well, here's the thing. I'll be really upset if any of you try to divide by 0. So the whole point is we can't have our denominator equals 0. It's kind of like when we did the non-permissible values or the restrictions, we call them restrictions, under the root sign. Because we knew roots had to be greater than 0 or equal to 0. They couldn't be negative numbers. Same sort of thing here, but this one's actually nicer to do because it's not an inequality. It's an actual, my denominator cannot equal 0. So this is the easy part. Set the non-permissible value, so the denominator equals 0, and solve for the value of the variable. Okay? All right. Okay, we're saying what it can't equal. So when we state our non-permissible values, we're saying that x cannot equal 2. So we're making a cannot equal statement. Not equal. Not equal. I don't know. This is bad. This is bad English today. Okay, when you simplify a rational expression, you must do your non-permissible values first. So the first thing we do is we do our NPVs. Okay? Then we do any of our simplifying. You guys ready? All right, so we are going to we're going to identify our non-permissible values for each expression. These are the hardest for people to grasp. You guys like flashbacks to radicals. I couldn't do radicals on these. I'm hoping. Okay, so 4s r squared. So I take the denominator, and it cannot equal 0. So we're going to solve that out. Now this one, mathematically speaking, isn't really exciting to solve. I want you to actually think about this one in your head. These are all multiplied together, right? They're all multiplied together. It's a monomial. You guys are everything because they're all true statements that I just said. Okay, so what can S not be? Here. What can R not be? Oh. All right, so we're done our non-permissible values. That's it. These are my NPVs. So when it's a monomial, you guys all know what I mean by monomial, so it's one term, there's nothing added or subtracted to it. Your variables can't equal 0. Pretty exciting stuff. Okay, that's it for non-permissible values. Okay, so I'm looking at B. So I've got 2 of them, right? I've got X, and I have 2x minus 3. Now, if we were to do this, you guys have done this a million times. You've done this for, what have you done this for? Solid quadratics, right? You factor it. It is in factored form. This is a foreshadowing of what's to come. It's in factored form. So then you set each factor equal or not equal to 0. Okay, so that one's done because it's a monomial. And what did we say about monomials? They just can't equal 0, right? So now here I just got to solve. So I'm going to add 3 to both sides. So I have 2x cannot equal in positive 3, that's a negative 3. Divided by 2. Divided by 2. So x cannot equal a positive 1/2. So there's a non-permissible value. And there's a non-permissible value. So it's like when we're solving for our quadratics from chapter 4, you can have more than one non-permissible value. Sometimes you only have one, sometimes you have more than one. For us right now, If I gave it to you in factored form, unlimited. If I gave it to you in standard form, probably only 2. Just because we don't know how to factor a cubic function yet, and we don't know how to factor anything higher than quadratic function. So 2. But I might give you 6 of these in a row if I gave it to you in factored form. And that can happen. Okay, so for this one, I'm going to set my denominator, or not, the big head's in the way. Are you guys okay with the cannot equal 0? Does that mess with you? I like putting it in up here because I'm making the same statement over and over again. I know my denominator cannot equal 0. And I have to state that these are my NPVs. When we go further into solve it, I expect to see your NPV and NPV statement somewhere on the page. These are my NPVs. These are what my variables cannot equal.
Cannot be, so when you have 2 on 0 and 3, have you none of them in between?
Nope, just those ones. So the nice thing is in radicals, we have that inequality, and that meant a whole bunch of things in between. But now, it just can't equal 0. I don't care if it's negative, I don't care if it's positive, I don't care if it's small, I don't care if it's big. It just can't equal 0. So there's only one thing that the denominator can't equal, 0. Okay? So it's a little bit nicer. I would say that these are easier than the radicals, restrictions. Okay, so you guys know how to solve this. You're going to factor it. Chapter 4 coming back. Yeah. Yeah. What if I did this? How do you guys feel? There's supposed to be a not equal sign. How do you guys feel with this, making them a list? Are you guys okay with that? And I did that all in my head for a Tuesday. I'm pretty proud of myself. So if I set this equal to 0, I'd add 4 to both sides, so that would give me my positive 4. And if it's a p plus 3 can equal 0, subtract 3 from both sides, that can be my negative 3. You don't always have to show all the steps. I probably have enough experience factoring simple trinomials that for my NPVs, I could look at this and go right to here. Or you can do it on a scrap piece of paper. I'd rather see the math that goes with it, because if you've made a mistake, at least then I can give you partial marks for it. Because you just don't look at that. All right, so these are my NPVs here. So sometimes I'll write them as a list, just because I want to save myself time. Who feels confident going from here to here? Okay. And if you don't, do the next step and solve it out. Okay? If that's what you prefer to do, then do that. But just because I can do it, or just because some of your classmates can do it, this is going to take you all of like a half a second to write this down. And if that's going to make it more clear in your head, then put the half a second in and do that. Okay. So, are we good? Did everybody get that copy down? Wasn't very exciting. Okay, example 2. We are going to start simplifying expressions. Okay, so step 1 is do my NPVs. All right. So, I'm going to have to write this one down. So this is a 2x squared plus x minus 10 cannot equal 0. So that's a complex trinomial. So I have 2x squared. I guess I'll do my negative 4 first, right? And the rest of you were just sitting there going, you crazy fools, what are you talking about? I take the 2 times it by the -10, I get -20. And then I look for the factors of -20 that add up to a +1. And then I'm gonna write those factors out. And now I'm looking at these two. And I'm gonna common factor, so I'm gonna take out a 2x, and that leaves me with x minus 2. And then I look at these two, and I'm gonna common factor to +5, which leaves me with x minus 2. You know you've done it right if this one and this one are the exact same. If they are not the exact same, if they're kind of the same, you've done something wrong. All right, so, okay, and notice that my can equal 0 keeps following me down. And if you lose one of those, if you've forgotten it online, that's a half-mark deduction because you've switched from an equation to an expression and then back to an equation, which is bad math. So I'm going to have 2x plus 5 and 2, no, x minus 2. I did that backwards to the way I normally do it, so that messed with me. I'm going to do this in my head. You guys are like, I don't like when she does it in her head. So x cannot equal, we do the easy one first. That one's a +2, right? Okay, this one, take the 5 to the other side, so it's going to be a -5 divided by 2. So those are things that I'm doing in my head, and that's how I think about them. This is stuff like I do this every day of my career, so I'm pretty good at it. I still make mistakes though if I'm rushing through it. So showing all your steps. So if I were to do a test tomorrow, I'd probably show all my steps, just so one, I can show off and show you I know how to do all my math. And two, make sure that I don't make those simple errors that I think we're all guilty of doing every now and again. Okay, so that's for nothing. Okay. Okay, number 1, NPVs. Good job, Ms. Ryan. Did that. Step 2, factor everything. And by everything, I mean numerator and denominator. And the good thing is you've already factored the denominator. You've done it here already. Okay? So don't refactor it because you just did it for your non-permissible values. So I'm going to jump back up here. So this is going to be, so I don't have an equal sign anymore, right? I don't have an equal sign because I'm simplifying because this is an expression. We're making an equation here for what x can't equal. We're making a statement about that. And then this was 2x plus 5 and x minus 2. Okay. So everything's multiplied. Everything's multiplied together. So now I can cancel stuff out. So this is step 3. So that was step 2. I don't know. I'm writing random things everywhere. Step 3. Cancel out if you can. So I've got a 3, and this whole thing has to stay together. You can't say, oh, look, there's a 2 here and a 2 here, so I'm going to cancel those things out. You can't do that. This is a package. You can't break it apart. It is one solid unit. So the only thing that I can cancel out here, x minus 2, because there's 1 on top and there's 1 on bottom. If I had 2 on bottom, you can only ever cancel out 1. Does that make sense? So simplified, it would be 3, 2x plus 5. And that's your simplified answer. With my NPVs, where x cannot equal +2 and -5 over 2. Are you guys comfortable with fractions? It's like, no. Fair enough, we're not, but I think we need to practice becoming comfortable with them. So I would prefer that you leave this as -5 over 2 instead of -2.5. Okay, so we're just going to practice with that. So that's your answer. There, you've simplified, you've got your non-permissible values, I'm done, I walk away. And that's all I can do with that. I can't solve it. I can't get this down to equal something. There's no equal sign in this, I'm just. Okay, so now we're gonna do these. So step one is NPV. I can do the NPVs in my head, I can factor this in my head. I'm just showing off today, I'm sorry. So my NPVs, so this is the difference of squares. And I hope that that's leaping off the page at you. So M cannot equal. And again, I'm going to be as efficient as possible. You can write M cannot equal 3, and then you can write again M cannot equal -3. I have no problem with that. You can do both of them. I have no problem with that at all. But I'm just going to write it like that because it's easier for me. And I probably could have gone from this directly to this. And if you can, that's perfect. Okay. So, step 2. Factor. Okay. So I'm going to write something down. I don't want you to write it down. You like that? Those are my favorite. So we look at this. I'm going to common factor to 2. I'm left with 3 minus m. And we've already done my factoring for the denominator. So that's kind of good. All right. So this is what I didn't want you to write down. Nobody wrote it down, right? Okay. So people are like, well, there's an m and there's a 3, and they're both subtractive. So I can cancel those out. Positive 3 to negative m. This is a positive m, negative 3. If you ever get into a situation like this where it's all the right numbers and all the right letters, but just the wrong signs, common factor the negative out of here. Because if it's a positive 3 and I take a -1 out of it, like 3 divided by -1, that's going to give me a -3. That's what I need. If I take a negative m and divide by a -1, that's going to give me a positive m, which is what I need. So instead of doing this, I want to cross that out. It's wrong because it's not really wrong. You're just not going to get it simplified. I'd take out a -2, and I'd be left with a -3 plus m all over m minus 3 m plus 3. So now these are the exact same thing. They're just written in a wonky order. Does that mess with you? Some people are really OCD about this stuff and they need this to look exactly like this. So they'll do another line and rewrite it. Is that you guys? I don't know what you're talking about. Would you guys agree that that and that are the same thing? Yeah? Some people, like, I'm fine if you leave it like this and then just cancel these out. Some people like to see them exactly the same. And so they'll do another line and they'll rewrite it. Again, it's a half second of your life. It's not going to, I'm fine if you cancel these out or if you write the next line. So again, I'm going to cancel out 1 on top, 1 on bottom. So I'm left with -2 over m plus 3, where m cannot equal. So this is most likely the way you're going to see it in your textbook or in your textbook answer key. They're going to have the simplified version. They're going to have the comma. And all that means is this is my simplified version where m cannot equal plus minus 3. So, yeah.
Then if you're in -2.6, it doesn't make
Right. I get what you're saying. So if you put a plus 3, it would be a third, right? But you have to do your non-permissible values off of the original before you simplify. That's why we do our non-permissible values first. Because if you put in a -3 here,
Yeah, but it's a square.
Right, so we always do it off the beginning before we simplify. And the connection we have to graphs here is these are going to turn into my asymptotes of things that x cannot equal. So there'll be holes in the graph at -3 and +3. So you're going to end up with a little bit, it's a really cool thing when you put in asymptotes, but they have to be done off the original. Okay? Because the original is going to give you, okay, so consider it like an essay. The original is going to be your final copy. It's going to be all the, okay, your original's like your English credit. Okay, we'll call it that. And if I only ever look at that final essay, maybe it's only 5 pages, but that doesn't show all the hard work you put into it, that doesn't show all the learning you've done, that doesn't show all the editing you've done, right? So we have to go back and look at this first. We have to look at how hard it comes.
What happens if you put a 3, like a +3 in that?
I'm leaving. Okay. Did I give you guys the, oh, this is exciting. This is exciting. This is exciting. No, not exciting? Okay, so step 1, NPVs. Step 1, NPVs. So I'm going to look at the denominator. Okay, so it looks ugly, but it's not terrible. What can I, this is a common factoring one. Okay, so what can I common factor? Take a 2. So if I take a 2 out, I'm left with 4x minus 3y equals 0. Does this have a variable in it? That's just a number, right? So I don't set that equal to 0 because I'm only looking for what the variable can't be. 2 is 2. It's just 2. So I have 4x minus 3y. You're like, this is stupid. This one we're going to write. This happens a few times in life. So why does this happen? So we write this in relation to each other's variable. X cannot be equal to 3/4 of whatever y is. Oh, sorry, I forgot the cannots. Thank you. So that's a really not exciting NPV because it doesn't pop off the page of you. Like when x can't equal -2.5, I know what that looks like. This one's a little bit more convoluted. It changes based on the value of whatever y is. So all I'm saying is those are connected in a relationship. Not a great relationship, not one that we want to see very often. You're not going to get a lot of these, but just so that you're aware and you're comfortable factoring with 2 variables. So that's my non-permissible value. That's exciting. No, it can. It can. Because it's related to the y. You have to look at both x and y values. It's telling you there's a relationship between the 2. It's not just 2. 4x factor. Okay. Okay. So what that all is saying is those are connected together. You can't just look at the x independent of the y. You have to look at them together. And sometimes that happens, very rarely. We're probably not going to go much further with this sort of stuff than this kind of question. We're not going to take it further. We're not going to graph it. I think we're going to leave here. Okay, so now we're going to simplify the expression. So I did my denominator. Now we're going to factor. So step 1 was non-permissible values. Step 2 is factor everything. Anybody looking at that top one and anything popping off the page of them? It's like, okay, perfect square. Yes, it is. Not -9. What about 9? Okay, what did we? Remember that one? We just did that one? What did I call that? Difference of squares. This is a difference of squares. Perfect square in the front, perfect square in the back. Do you guys remember this? Grade 10? Did we just do this?
Yeah, literally.
Yeah, in chapter 4. We learned it in grade 10. So this is going to be 4x minus 3y. Okay, my grade 10s. Thinking about this. And it's factored already, so this is going to be 2, and this will be 4x minus 3y. Okay, so now step 3. Step 3. Mr. Cancel step. This is the fun stuff. So I'm going to cancel out this one and this one. Okay, a kitten will die. Serious stuff. If you take that 2 and only put it into the 4. Because what did I say about the stuff in the brackets? Can't break it apart, right? So the 2 would have to go into here and into here. So you can't just put the 2 into the 4. Don't do that. A kitten will die. You'll be a monster. And I don't want to see any of you turn into a life of kitten abuse. So I stop here. And then I say where x cannot equal 3/4. A monster.
I put the 4 to the 2.
No, it would be that if it was squared. This is just saying 2 times that. This would change it to 8x plus negative or minus negative 6y. If it was, if it had a square there, absolutely, it was one of those would still stay on the bottom. But I would never write anything as a square because in step 2, I have to factor everything. So I write all my factors so I don't screw that up because that would be something I would do for sure. Okay, so the comma means where. So this is my simplified answer, where x cannot equal 3/4 of whatever the y value is. Okay, so part C. So I did A, I did B, now I got to do C. So it says evaluate the expression when x equals negative or positive 2.6 and y equals 1.2. This is what we're going to do. You guys are going to put it into the simplified expression. I'm going to put it into the original. Okay? So that's your job. You guys are going to do the simplified. I'm going to do the original. Okay, notice I have no equal signs anywhere, right? You guys don't have any equal signs anywhere on your page, right? Because we're just substituting in, there's no equal signs, we're working down the page. That's where there.
Is it 108.16?
That's what I got. I'm going to do it as hard as I am on Tuesday. you guys get? You guys get 7?
It becomes 14 over 2.
Okay, what did I do wrong? You think I divided it wrong? Oh, I did. I totally did. 95.2. I wrote it down. I got 7. That's a 7. I don't know how you guys handled that. Look, I'm having a hard enough time. I was showing off my factoring, and now the universe has just put me in my place. I was too much showboating, and now the universe is telling me. Okay, so a couple of things that you should have noticed. You guys got 7. Took me a little while. I also got 7. So when you put it into the original, or when you put it into your simplified version, you should get the exact same answer. Okay, word of warning, or word of subcaution warning, I don't know what this is. If you made a mistake somewhere you're simplifying, you're not going to know that on a test or a quiz, right? So if I asked you to do a substitution question like this and you get 1.53 for an answer, that's just bad math, so you're going to get a deduction of a half mark. But if you're simplifying this incorrect, but you substituted and solved correctly to get that answer, it would still be wrong, but it'd still give you full marks for it because it's what's called a follow-through error. You lose marks in the simplifying part because you did something wrong out there, but you get full marks for part C if you simplify correctly. Does that make sense, everybody? It's called a follow-through error. So just know that you can do it in either place. And what would you guys rather substitute in, the simplified version or the original version? Probably the simplified because it's simpler, right? Like, obviously, there was more numbers, and I was hitting buttons.